So let's begin the start of the last notes that we're going to take for this year. And this is our intro to calculus. You're going to be spending a lot of time next year talking about all of the topics that we cover today and for this chapter. So we're going to just touch on these and you'll get more in depth as you go on next year. So the first topic that's the building block for calculus are limits. Limits are just like speed limits you've seen, or they're an endpoint that we want to get. So you'll see this notation often written. We read it as the limit as x approaches c of f of x is equal to some number, whatever that number is. So this first lesson, we're going to be using our calculators to figure out and make tables to figure out where the limit is as we approach certain numbers. So if you have your calculator, and if you did look at the top, it does say in-class activity. I will show you guys how to do this more in class, but for this video, I'm going to try and walk you through as best I can on how to use your calculator. So I'm just going to zoom in a little bit, turn on that screen. So I'm at the home screen. If you're not, you can always hit the home button, which is right here. So I want to create a new document, and no, I don't want to save the changes. So when you first create a new document, we want to add a calculator, okay? So we're going to add a calculator. Now, we also want, if we hit document, we want to insert, we're going to be making a table, so we want to go to lists and spreadsheets. So we have these two. To go back and forth between these two pages, if you just hit Control and the arrow to the left, you jump back. Okay, if you look at the first problem, it says we want to find the limit. Let's just put that back on the screen just for a second. We want to find the limit as x approaches 3 of 5x squared. So in order for your calculator to know how to do this, we first need to define our function. So if you hit Menu and go to Actions and go to Define and hit Enter, we're going to define our function. So let's call it f of x. So we can say f parentheses x equals, well, let's put the equal sign on the outside, and then we want 5x squared. You hit Enter, it will say done. That's what we want. Now, if we hit Control and right, we go over to the spreadsheet. So once we go over to our table, we want to get to this is a spreadsheet. We want a table. So if we hit Menu and we go down to the table part, we can say switch to table, or we can hit Control T. I like just to do that. Okay, now we have our table, but we don't have a function. So if we move our mouse up to this arrow and just click it, we get this f of x that shows up. And if we click f of x, there's our function. Now, it is auto-generating numbers. So like if we scroll down, it's 1, 2, 3, 4, 5, 6, 7. We want to ask the numbers because we want to get closer and closer and closer to 3. So what we do is we hit Menu, we go down to Table, we go to Edit Table Settings. And what we want is we want our independent variable. We want to ask that. We want to enter that number. Okay, so now we should have our x value and our f of x value. So we're trying to get closer and closer and closer to 3. So let's pick numbers to the left and to the right of 3. So we can start with 2.9. If we hit enter, we get 42.05. That's kind of close. If we went to 2.99, that's really close to 3. If we go to 2.999, we're getting closer and closer and closer for x to be 3, but we're not actually being 3. So one more, 2.9999, we get, and just to show you guys, if I just select that, we can get all of the decimals there. Okay, what happens if we're to the right of 3? What if we're at 3.1? 3.1 we're over. 3.01 we're really close. 3.00001 we're closer and closer. And if we, one more, 3.0001. If we look at from the left side of this function or the right side of the function, we're trying to pin down what value this is going to be. So we can easily see that f of x squared is defined, but the limit from either the left side or the right side is getting closer and closer to 45. So we say on this problem, the limit using a table as x approaches 3 of f of x squared is 45. And that's just from our table settings. All right, let's try our next one. So find the limit using a table for this function. Okay, so we're going to go back to our calculators. We're going to hit Control left arrow. We're going to define a new function. So we hit Menu, Actions, Define. And then we're going to say, let's just call it g of x. G of x equals, we're going to put parentheses around it, x squared minus 4 divided by, parentheses, x minus 2. So we type that into our calculator, we hit enter, it should say done, so now our function is g of x. So now, if we go back to our table, we could clear out all of these numbers, which would take a while, right? You can also hit second control. And that could delete them. But what we really want is to switch our function over. So if we go up to this arrow, and we're going to select our different function, g of x. And the numbers that we're getting closer and closer to for g of x was 2, just to check. So we want, if we plug in 2, we get undefined. So something's going on for this function. But if I go to the left of 2, so let's say 1.9, I get a number. If I go 1.99, I'm getting closer to 2, I get a number. If I get closer and closer to 2, 1.999, I'm getting closer and closer to this some number. But if I plug in 2 to this function, I get undefined. What if I'm to the right of that number, let's say 2.1. So I'm an overestimate. Or 2.01. I'm getting closer and closer. 2.001. I'm getting closer and closer to some value, and that value is 4. So using this table, if we do even closer, we're seeing that the power of limits is sometimes where functions are undefined, we can still be approaching some value. So we said that this number is approaching 4. So what about example 3? Let's quickly check example 3, because we should see that this is a pretty straightforward one. So we go to define, let's say h of x equals x plus 2. So now I've defined my function. Now I'm going to just tab over. And what I want is to switch this g of x to h of x. And I'm still approaching it from the same number from the left and from the right. So if I look here, x plus 2, if I plug in 2, I get 4. Likewise, if I look to the left and to the right of 2, I'm approaching 4. So example 3 and example 4 have the exact same limit. I'm just going to zoom out for a little bit so we can see both of those. And let's think about why. you can look at example 2 and you could factor the top. So we could write this as the limit as x approaches 2 of x plus 2, x minus 2 over x minus 2. Now, from our algebra skills, we know that we can cancel these out. And we'll just say this is the same thing as the limit as x approaches 2 of x plus 2. These two limits are equal because these two expressions are the same thing. So let's flip it over, and we'll try a couple more using your calculator, and then I'll show you how to graph using the TI Nspire. All right, so on the back, we have this interesting limit. This one is super important, and you'll need to know this limit throughout most of your calculus career. It comes up over and over and over again. So it's important that you know this one. Okay, so calculator. Let's zoom in so you guys can see that. I'm going to define a new function. So I'm going to go Menu, Actions, Define. Let's say m of x equals trig sine x divided by x. So now we've defined it. I just want to double check. If you move your mouse over to the battery, you can see what your angle measure is in, which is in radians, which is good. That's what we want. So just for our sake, to make it easier, I'm going to go to Insert, Menu, or Document Settings, Insert, and I'm going to insert a new spreadsheet. And I'm going to do the same thing. Menu, Table, switch to Table, and I want M. And if I hit Menu, we can already see what's happening. And I want to go to Table Settings. And if I tab down to Independent, I want to be Asking. Okay. So here's our function m of x. We want to look to see if we're getting closer and closer to 0. So what values do I want to plug in? I want to be to the left and to the right of 0, because if I plug in 0 to this function, I get 0 over 0, which is undefined. But this does have a value. So let's try, see if I plug in 0, I get undefined. So let's try negative 0.1. Okay, that's 0.99. If I did negative 0.01 to get a little closer, okay, 0.999. If I did negative 0.001, okay, I see that I get 9999999. If I did one more, negative 0.0001, really, really close, I get 99999. I'm almost at 1. So it looks like from the left side, we are getting closer and closer to 1. What if I plugged in 0.1? So if I went from the right side, and if I went 0.01, or 0.001, or 0.0001. Each time, I'm getting closer and closer and closer to a value, and that value is 1. So we say that the limit as x approaches 0 of sine x over x is equal to 1. And we can infer that all from its table. So that's using tables with your graphing calculator. Now I'm going to move on to graphing these by hand and seeing what happens with some of these functions. So for examples 5 and 6, it says find the limit of a given function by graphing it. And here we are asked to graph two different functions. These are called piecewise functions. You should have seen these at the beginning of pre-calculus. And we graph them in pieces. So you read this as f of x is 3x minus 2 if x is not equal to 2. So how do you graph that line? Let's draw our graph. We go down negative 2. That's our y-intercept. We go up 3 to 3 over 1. Up 1, 2, 3 over over 1. But in this case, we put a open circle because at 2, my line is not that value. So what is my value when x is 2? When x is 2, y is equal to 3. So we have this other point. Let's just do it in another color so it stands out. This other point here that's filled in at 2. So let's say I was looking at this, the limit of this graph. If I was coming up this way, this way, this way, I'm getting closer and closer to this value right here, which is 4, right? If I'm coming up here, I'm getting closer and closer to 4. If I'm coming back the other way, I'm getting closer and closer to 4. I'm tracking on this line. But at x equals 2, we get a value that's 3. But if I asked you, what's the limit as x approaches 2 of f of x? We would say the limit, if we looked from the left and from the right, is 4. Even though at 2, it's 3. This is a discontinuity, but it has a limit. Let's try example 6. Maybe it'll be a little more clear. So again, piecewise function. So we have our graph. We have f of x equals x for x is less than or equal to 0. So how do you graph x? And it's less than or equal to, so it's filled in. So we have that. For x is greater than 2, so 2, we have an open circle. So if we look at this, graph, it's kind of weird. We have a line, line with slope 1, and then we have a line with slope 0. If we're looking closer and closer for x to be 0 from the left, we're getting closer and closer to 0. But if I look from the right, I'm not getting the same thing. So if our graphs are discontinuous and they're not approaching the same value, we say the limit does not exist. So that takes care of the first section. If you have any questions about using your calculator, or if you have a TI-84 or TI-83, I can show you guys how to use and make the tables for yourselves using those calculators in class. Otherwise, we're going to move on to the next section.